Yes, today we are doing I guess it's our second of our new semester of classes this year. Based on feedback from last year, people wanted us to get a little bit more into technical detail, which makes perfect sense. And of course, I immediately thought, oh, we need to have Silviu on. Silviu is going to be talking today about augmenting terrestrial LiDAR with photogrammetry, which is a super fun topic where you get to learn about some new tools we haven't talked about much in past classes. So super pumped about this. It's gonna be fantastic. Quick housekeeping stuff, of course, as always, everybody's muted. Please ask questions via the kind of questions tool in GoToWebinar. We will answer those at the end of the session. We'll try and wrap up with about 10 minutes left to do that. The webinar is being recorded. So if you have to pop out halfway through, if you come in late, you won't hear this, but we'll remind you when you ask later. Otherwise, it's all recorded, so you can watch it later, share it with your friends, et cetera, because it's going to be great. And then the link will go out probably about a week after the class. So with that, Silviu, I want to do a quick little introduction, and I'll just go ahead and turn over the presentership to you while you're talking.
All right.
Right. All right. You are presenter.
Perfect. All right. Let me switch here to the right application and we can get started. All right. All right. Thanks for joining, everyone. This is quite an interesting topic. Ellie and I and other people in our circle, we've been playing and experimenting with photogrammetry for quite a while. This time, I think for the last few months, I was able to find a lot of benefits utilizing it. So my name is Silviu. I run a very fun company called RC Monkeys, and we are specialized in building documentation of historic preservation projects, adaptive reuse, and renovation projects for buildings that have a historical value. And today we'll be trying to improve our experience with photogrammetry when it comes to documenting buildings. So I want to give you a quick background in what I was trying to solve by implementing this process or changing our process for certain types of buildings. So what was the problem that we're trying to solve? And in most cases was coverage, especially for exterior scans, trying to get to high elevation areas, roofs, eaves, window sills. Things like that was either too risky or we didn't have the equipment to do it. There were instances where we had to travel and it's not very practical to carry with you an elevating tripod, or maybe the building is a little bit too high for those tripods. So I was looking for a solution to increase the coverage. That was the problem that we were trying to solve here. And this was for very particular projects that were in on our schedule, and we were trying to see how can we capture the roofs in order to document them, to model them. And about 9 months ago, I was just browsing and just scrolling through LinkedIn, and I saw this post, and I just want to share this post with you because that's where kind of piqued my interest to look at photogrammetry again as a solution for this. So I'm gonna switch and share this LinkedIn post, and this is done by a company in UK called Architectural and Heritage Scanning. So I'm just gonna play a few seconds here, and what they're showing is this photogrammetric mesh, and they were zooming in, and you can see all these the writing on the wall, and I said, whoa, this is quite something. And we experimented with photogrammetry in the past, but I didn't see anything like this, right? And then I started researching this process, and I realized that you know, they're using a tool that I've never used before, and they're combining laser scanning data with photogrammetric data. So I want to test this out and see what is the accuracy that we can get out of this process, but also I could see some other benefits that we'll discuss a little bit later. So I'm going to stop this and switch back to the PowerPoint presentation. All right. So we're trying to solve coverage, right? So we saw that video and we started researching. We started reading forums, blogs, and we implemented or tested that process. You know, we purchased the equipment, and then you know, we had pretty good results. So for the last 6 months, we implemented the process on most projects that have a historical value, because we can get a much better experience when we take that data and we convert it into 3D deliverables like models. All right, so what is the equipment that we need in order to implement the process? We'll talk about equipment. We'll talk about the field workflow, you know, some tips that you need to be aware of when you're capturing your data in the field. We'll talk about some camera settings and maybe some sweet spots that you want to follow when you go out in the field. How do you manage your images? And then we're going to do a demo. Hopefully everything will go well with a live demo, but we'll demo a tool, and we'll show you how to register or align those scans with the photogrammetric data. And then we'll show a few examples, some deliverables that can be generated as a result of implementing this process. And then we'll talk about some of the benefits that we were looking for, and then some other benefits that we discovered while we worked with these deliverables. All right, so let's look at the equipment. So obviously we mentioned LiDAR and photogrammetry in the title today, and we need to capture the site, and we obviously going to start with a scanner. And you know, people have different tools already purchased, and I would recommend using scanners that have very good onboard cameras. Obviously, here in this image we have the RTC 360, but we've tried it with the ZNF Imager 5016, with RTC, with Faro S series, and all those work well as long as they have good onboard camera. Then that should be good enough. And then we're talking about those high elevated areas, those risky areas that you might not be able to capture with a scanner. This is where having a drone comes in handy. And the drone itself is not that important. What's important is what's hanging underneath it, and that's the camera. The sensor, the camera is going to matter more than the drone. I'm curious to see what the new Mavic Mini 3 Pro was that. How is that going to improve the process? It seems to have a very good sensor. And then for ground photography, we're going to need a very good camera. And there are a lot of cameras out there that are extremely good for this process, but probably the best value for your money you're going to get with the Sony A7 series, A7 II, A7 III, A7 IV, and especially with the latest versions, you can get a very high resolution images up to 61 megapixels. And then in order to get at some higher elevations, you might need some accessories that will come in handy for the handheld camera. Also, if you're shooting in very dark conditions, having a tripod is quite important to avoid those movements and shakes That way you can, use some different settings that will allow to shoot in those conditions. All right, so in the field, what are some of the things that we've learned that apply to this process, right? So you can, I'm sure a lot of you that are watching this, they've scanned for a long time, but unfortunately, not all the scans are created equal when it comes to using that data in aligning it to a photogrammetric model. So this is what we've learned, that usually in order to get some good results, you need to go with a minimal resolution of 6 millimeters at 10 meters, right? So that's about 1/4 of an inch at 33 feet. That seems to be, I would not go lower than that, because then the images that are being created out of those scans are too low resolution and not good for alignment. For exterior scans, I would go with 3 millimeters at 10 meters, and then make sure you have that HDR enabled, and obviously you need to scan in color. I've heard some people actually using grayscale for photogrammetry. I haven't tried it, so I'm not sure exactly if that works or not. In terms of aerial and photography in general, for this process, the ideal condition is when it's overcast. The clouds, they act as a diffuser, exactly like if you use an artificial light source for photography. The clouds work the same way. They are diffusing the light, and then you have a nice homogeneous light on the surface of the subject. But we cannot control the weather, so we'll have to deal with whatever conditions we have that day. But ideally, if it's overcast, that's when you get the best results. And then fly different types of missions, top-down grid, and then orbital, just fly around the building. And some of these, they can be automated depending on the drone. And then probably, if you're doing a lot of details on the facade, you'll have to fly manually and do a vertical grid. And then, adjust the camera settings based on the light conditions. So we found out that just shooting in, automatic mode, it's not gonna work. You don't want to let the sensor and the application to change the camera settings with every single shot. So you need to make sure that you have the ability to adjust those settings manually. And sometimes you need to adjust them, every few photos. And then, have 60% overlap. The higher the better. It's the same as doing a cloud-to-cloud registration. And then the last one, make sure you do a sequential capture. This is gonna make your life easier when you have to align those photos in your application. And then for the ground photos, the appropriate focal length, so the type of lenses that you're using, is gonna matter a lot. We found that for interior spaces, especially tight spaces, using focal length between 18 and 24 millimeters is probably ideal. And then for exterior, between 24 to 50 millimeter, higher than that, you're gonna get some compression of the background, and it's not recommended. I usually go with 35 millimeters for exterior. That way, it's pretty much the same as what you see with your naked eye, and you always shoot in manual mode. You have to change your settings with every single photo. Check to make sure that you have the right exposure with every single photo. And then the same recommendation as for the aerial photos. Have a lot of overlap, 60% minimum, and then do a sequential capture. Just take a step, take a photo, take a step, take a photo. That is the workflow. All right. So the next is the camera settings. So we'll take a look at what we need to look for when we take these photos. So what is the goal here? And there are three things that we're after whenever we're taking these photos. Make sure that the entire the entire image is in focus, right? And we have the proper exposure. And then the last thing, there's no motion blur. And when it comes to motion blur, when we talk about the aerial equipment, the drones, there are some drones that they have a mechanical shutter that prevents this motion blur, and there's some that they don't. Like, for instance, the Mavic drones, they don't have a mechanical shutter. So you need to take that into account if you do any automated missions, and you need to adjust your shutter speed to make sure you avoid that motion blur. For the mirrorless cameras, those have a mechanical shutter, so you shouldn't have any issues there. And you're not running with the camera anyway. So I don't know if you have seen this before, but this is a exposure triangle, right? So there are three settings, major settings that you can adjust when you're in manual mode for both the drone as well as the mirrorless or DSLR camera. And that is the ISO, that's sensitivity to light, that's aperture, that is how wide the sensor is opened, and then the shutter speed, for how long the sensor is being exposed to light. And by combining different values for these three settings, you will get you'll make sure that your image is in focus, you have proper exposure, and you avoid motion blur. Obviously, for motion blur, the faster the shutter speed, the better. And for aperture, there are a few sweet spot settings that others recommended, and we just tested them to see if they worked. If we had different experience, and then to understand these settings better, I think this is a good graph here. I mean, you can find this online, kind of what happens if you have a much open sensor. You get that blur. Probably you see in my background. My background is blurred that way because we have a f-stop of 1.8. But increasing the f-stop, then you have a much you avoid that shallow field of focus. And then with the shutter speed, you can see the difference. What happens if you keep that sensor open for half a second, a quarter of a second. And then with the sensitivity to light, you get a lot of noise once you increase the ISO. Obviously, if you're shooting in low light conditions, you'll have to increase those that ISO will be higher. So you need to learn what your camera, how your camera performs in those low light conditions. So in terms of the sweet spot, you want to keep your ISO between 100 and 800. And I would always start with 100 and try to adjust the other two settings. And then if that doesn't get me to the right exposure, then I'll increase the ISO. The shutter speed, 1/50 seconds. That is, I would not go any slower than that. You will risk of getting that motion blur if you do. And then f-stop between 8 and 11. We're experimenting with f-stop, and we're trying to do a lower f-stop, and it works well if you're shooting ortho photos. So everything that's in the same plane, it will be in focus. But once you shoot at an angle relative to your subject, then you'll have portion of the image that's going to be in focus and others that will be blurry. So in between 8 and 11, that's usually the sweet spot. If you go higher, you might get some artifacts. You can search that. You'll find a lot of information about what happens when you shoot at a much higher aperture. All right, image management. This is something that I looked online before we started implementing this workflow, and actually we borrowed the naming convention and image management or organization from a company called SciArc that are known for their very high quality photogrammetric models. So the idea is that you want to group your images, and you group them by camera type, by area, as well as by lighting conditions. This way, the images will be processed faster. That is the goal: is to make sure that you process the images faster, as well as you don't want to do any manual work during that alignment process. So again, the naming convention is inspired by a post that was done by SciArc, and this is how we name our aerial images. We have different naming for aerial grid, aerial ring, and orthos. For ground, we have a naming convention for exterior and interior, and this is a file name example. We have the project name, we have the type of mission or photograph, and then we might have different areas. So it's like 01, that's one area, and then the picture name or the image name number. I'm sorry. All right, and a pro tip: if you wonder how you're gonna rename all those images, this is a recommendation that was given to me many years ago by somebody that I worked with, and this tool, bulk rename utility, works pretty well. Just don't forget to donate to these guys. The tool is free, and just give them a few dollars for all their work and for maintaining this tool. All right, and before we start the demo, one thing that I wanted to mention is that when you're shooting your images, I would recommend shooting in RAW rather than JPEG. That way, it will give you some flexibility to post-process to correct some of those exposure errors that you might have. All right, I'm going to switch now to our processing application. All right, so we're using RealityCapture. RealityCapture, it is owned by Epic Games. It was developed by a company in Slovakia a few years ago, and it does quite an impressive job. So the first step is to get your images imported. So we'll do that. We're going to start with our aerial images. Today we're going to do a demo of a building that we captured in Savannah about a month and a half ago. And the reason why we captured this structure was to do some analysis, some deviation analysis, or plumpness analysis, more exactly, of all their facades. And just combining the terrestrial scanning with photogrammetry was a great example of how this process can help. So I'm gonna just drag and drop the images in the application. So they're all in here. And these are all the drone images, and you can see that they do have GPS coordinates. So the next step, once you brought them in, you're gonna go to your alignment tab, and also before you start any work, you need to make sure that you're going to clear your cache from the application. That way, everything's gonna run much smoother. So make sure you clear your cache, and then you're just gonna hit align, right? So obviously we're not gonna wait for these images to align. I have the project saved at various stages. So I'm just going to open another project that had those images aligned. So let's do that. All right, so this workflow, the way we're going to work in RealityCapture is we're going to utilize a workflow called, we're going to break the projects into components. So basically, what a component is basically a group of images that they were aligned together. And the goal of grouping or using components is to align quickly and precisely without any manual input. And it's the same as when you're registering your scans. If you do scanning, you basically are going to break your registration into sub-registrations and then bring those together in a master registration. The same workflow applies in RealityCapture. You're going to use your components as your sub-registrations, basically. And we're gonna start from the small areas, and then we're gonna end up with the entire project at the end. The master registration or the master component. So what we have here, this is the component that was created, and we can see that we have 312 aerial images. They're all aligned, and if we click on the component, let me switch this to a 3D view. So we can see the all of these are the cameras, and in this case, we didn't fly an automated mission. We're using a Mavic 3, and unfortunately, that drone is not supporting automated flights. So we tried to to fly it in a grid manually, as well as we did all these orthos of the facades. So after you align your first set of images, you're going to do a quick check for any misalignments. And as you can see, we do have a problem here. If you look at this roof, you can see another line here. So there's some error in the alignment. So the only way you can tell if you have any misalignments is by visually checking your alignment. So what you see right now on the screen, this is not a point cloud. These are all the type points that were generated as a result of finding common features between all of these images. So what we need to do is to fix that misalignment before we move forward. So you can obviously realign the photos by changing some settings, some alignment settings. So you have a few options here. You can set the image overlap to low, and then also change the detector sensitivity to high or ultra, and that might fix it. But if that doesn't fix it, there's also another solution, and that is using control points. If you're doing scanning, it's pretty much the same concept as using targets in the field. So we're gonna use, we're gonna create some, let's say, virtual targets. All these controls are gonna be virtual targets that allow us to fix that problem. So let me show you how to create those control points. I'm gonna create one or two, and then we're gonna jump to the project that already has those control points already added. So the first thing is you go to the alignment tab, and then you're gonna click on the control points here. And then when you hover over all of these type points, you're gonna see all these projected lines, and those are projected lines from all the cameras, all the images. So basically, what it tells you. Also, we're gonna change here the view from 1+2+2 layout. That way, when I hover over, it's gonna show some of those images on the in the other windows. So I'm going to click anywhere for now, and we can adjust that point later. Right, so right here, this is point 0. You created control point 0, and that pixel that I picked is in all of these images that are listed. So what we're going to do first is select one of these images and try to find a easy to spot point that we can pick in all of those images. And usually I pick points that have some high contrast. So let's do that. We have point 0, and I'm going to try to see if we find, or maybe change that to, okay. All right, so let's find a point of contrast. So, you know, one thing that we can do, maybe, you know, pick that spot right there, and you know, we move this point. We're gonna move it right there, right? We're gonna do the same thing. So we already confirmed the location of control point 0, and you can see that the image here on the left side, it turned white. So we're gonna click on another one that's grayed out and try to move point 0 to the same location. So we're gonna grab it and then hold down the left mouse button and then just try to move it in that location. So now we have even more points, or you know, the point was found in even more images. So we have more images listed here on the left side, but the location of the control point is not yet confirmed. So what we can do is select any of these images, and now we'll see that the location of that control point is somewhat correct. So we need to make small adjustments. One trick to do that, you select it, and then while you hold the left mouse button down, once you have it in the right location, you just hit the down arrow. It's going to move to the next image. So you can go through them pretty quickly. Make adjustments. Make adjustments. You can see that on the left screen, on the left side of the screen, all of those images are confirmed. All right, so this is the process of adding your control points when you try to resolve a misalignment within one component. Right? You have a few more. I mean, you can either you know, add these ones as well. This is not a good one, or you can just discard them. All right, so you follow this process until you add, you know, you need quite a few control points, and I forgot how many I added to correct this mistake. But what we can do is close this project and then open the project with all of the control points added. And I believe we fixed that issue very easily. All right, so we'll open the next project. So you can see I'm going to switch here, the layout 1+1. So we added 7 control points. And so now if we check the alignment, basically once you add all of those control points, you just hit align images again, and that should take just a few seconds because you already had extracted all of the common features between images, and you know, we resolved the issue. So once you have this valid registration between images, you're going to save this registration. So basically, you select the registration in here, and then you export your registration. And we already have one exported. And basically, the only thing that is going to do is going to store all of those all that information, the alignment information, the image information, and the alignment information. And that's pretty much it. And you can use this as your sub registration or subcomponent in tying everything together. All right, so let's take a look at the alignment of the exterior photos done with a mirrorless camera. So I'm I'm going to close this and open a new project. Sorry, I think I have a, no, open another one. Here we go. All right, so in this particular case, what I did, I removed some of the images in the, so I'm gonna go to view and make sure that my cameras are visible. So, and increase the size of these cameras. So what I did here, I removed some of the images that were done at this corner to tie the south facade to the east facade. And because of that, we had some alignment issues. And instead of having one component at the end, we have two components. And this is usually what happens if you don't have enough overlap, or maybe your photos were not done in a sequential order. So if you don't have enough overlap, unfortunately, the only solution to tie those two components together as one component is to use control points. And the workflow is pretty much the same way. The only difference here is that you need to make sure that the control points that you set in one component, they need to be in the other component as well. So the workflow is similar, but with a small difference. So let's add one of those control points in here and demonstrate how to add the same control point in two components. So we're going to go to the alignment tab and then add a control point. So I'm going to select, switch my view to 1+1, and let's do a point somewhere here on this window header. So you can see we created control point number 5, and it found that pixel in a few images. So I'm going to make an adjustment here, and let's say control point 5 is going to be right there. That's an area of high contrast. So I'm going to adjust control point 5 at the top of that brick. Right. So I'm going to adjust it in this image as well. And then after I do that, all the other locations will adjust automatically. So now if I go, this is not a good example. The angle of incidence is too sharp. The same for that one. Let's leave just those two images. So we have control point 5 in two images. So if we open component 1 and we switch to 1+1, deactivate add control points, and just pan around, we can see that in component 1, we still have only 5 control points. We have from 0 to 4, we don't have point number 5. So what we need to do is to make sure that we add that in here. So in order to do that, we're going to activate add control points again, make sure we have 0.5 selected, and then I'm going to switch to 1+1 again, and then just add the control point. It doesn't have to be perfect. We can make adjustments later. So we added a control point right there. I'm going to open these images, and then I'm going to adjust the location of that control point. Let me see if we have a much better. All right, so this is where the control point, 0.5 is. I'm going to make an adjustment and in a couple of images, and that should update the location of control point 5. All right, so now I'm doing the same thing that I did earlier. I'm holding my left mouse button and then I'm hitting the down arrow. Now I added those control points in a few more images. Right, so now if we open component 1, we're going to switch to layout 1+1, and now we have control point 5. So we have it in both components, component 1 as well as component 2. So now if we hit align, these control points will help create one component. So let's take a look at that. We'll open the other project. So now we have one component. You do the same thing, you export your component, your registration, and then the next thing is to start our alignment to the scan data. So let's start a new project. And once you're ready to bring your scan data, you have a few options here, and you can bring a few file formats. You can bring PTX, E57, apply, or the ZNF format. And we have E57s, and let's select one of them for now. Let's do one that's small. And you're going to have this dialog box. And since these are registered, we're going to use the same registration, the exact same registration. Or we don't want things to be realigned. Are these geo-referenced? These ones in particular, no. These are color scans. And then if you're using a P20, you have a profile for a noise profile for the P20. If not, just set it to noise free. And then if you want the output path, so what he's going to do is create basically a 6 images or 6 files for each scan, basically all images that will create a cube. And you just select the path where those files will be saved. So and then hit OK, and then it will just convert those E57 files into the file formats needed for alignment. So we're going to cancel this, and we can actually bring the those converted files directly in here. So we bring those in. All right, so these are LSP files. I just drag them in, and you can see that this is a point cloud rig. So basically, what it does is it just uses the scan as your anchor. Once you bring these in and they're registered, all of the other registration or the components will be tied to the point cloud rig. So you brought these in, and then the next thing is you need to hit align. This is only going to take a few seconds because already registered. So just it takes probably 10 seconds or so. All right. So what you can see in here, these are all the type points that were created from those scans. So these are the cubes. So each scan was converted into 6 images, and you can see when I hover over those faces, the LSP files are being highlighted on the left side there. So the next thing is to make sure that you're going to lock all of these. So make sure that the lock pose is set to yes, and the prior pose is set to locked. That way, these will not go anywhere. So the next thing is to bring your components in from the aerial and from the ground photos. So we'll do that. I'm gonna go to workflow, and then we're going to either drag and drop. That's probably the easiest way to do it. We have our components already saved.
And just so you know, Silviu, we're not seeing your Windows Explorer windows.
Yeah, unfortunately, I cannot. I'm only sharing. Yeah. I can only share one application. So now we have these two registrations, two components. So the thing that you need to make sure that we need to set the position of all of these components to unknown. So you can see that the aerial already has is georeferenced. So in order to let them move to the scan data, we need to make sure that we set this to unknown. So you can either open your inputs and select all of the images in here, and then make sure that your prior pose is set to unknown. So now you saw that the GPS location from all of the aerial photos it went away. Right, this will allow the those components to move and align with the scan data. So the next step is to instead of hitting align images, we don't want to realign images. We want to make sure that the components are being merged. So the next step is to have those components merged. So that's you just hit merge components, and then just let the software do its thing. And a few minutes later, you should have everything aligned if you follow the workflow properly. So we're going to open a project that has all of those components aligned. All right. So now we have a master component that has everything aligned. We have the aerial, we have the ground photos, as well as the scans. You can see the cubes in here. So so right now we basically combined the aerial, the ground photos, and the scans all together in one registration. So you can see that we have the roof, and we have some other building elements that they were not visible in the terrestrial scans before. So once you're at this point, we need to build a model, a mesh model, and then texture it. And I'm just looking at the clock. We might probably skip that because we only have 10 more minutes. And I want to show you the deliverables, but as a workflow, that's basically how it works. It's similar to what you're doing in the registration of point clouds. You're working with components, sub-registrations, but you want to use the point cloud as your rig, as your anchor. And then everything is going to, if you're following the workflow properly, everything should be done pretty much automatically for you. Just a lot of time waiting for it to process, especially for the next two steps, which is building the mesh and then texturing the mesh, which is basically taking the information from the photos and applying it on the surface of the mesh. Once you have that mesh, so we can open that quickly, you can export a few file formats. So we have so I believe for this project in particular, just to build the mesh took about 2 hours, and then especially on this machine that I'm using right now, and then probably another 3 hours for texturing. So so from this project, we can export point clouds, we can export meshes, as well as we can generate some very nice ortho photos. So I'm going to switch to recap and show you some examples of how these deliverables look like. So initially, we wanted to make sure that we captured the roof and some areas that were not visible from the ground. But we'll talk about some other benefits that we realized once we started using these deliverables. So I'm going to switch from this application to the recap. All right, so this is the same project. What you see here on the screen, this is the point cloud captured with the scanner. So you can see all those areas that were not visible from the ground level. So line of sight was an obstacle in letting us capture the roof line, and also we're missing the window sills and some other building surfaces. So, and also this was colorized, captured in full resolution. We imported the images at 4K, which is probably the optimal resolution for the resolution that we captured the building, and it's pretty good. But if we switch to the point cloud that was generated from RealityCapture, so you probably saw an instant improvement, right? Colors look much better, and we have a consistent colorization. We don't get that edge bleeding, that parallax that we get from the scanner, and the data is nice and crisp. And there's even though we have less points, it doesn't look like we have less points because we have that great RGB values for every single point. So now we have the information for the window sills, and then we have the entire roof. We can see behind the parapet. We have information that we didn't have before. So initially, we just wanted to increase that coverage. That's why we were doing this. But then we realized that the quality of the point cloud in terms of images, colorization is so high that we can use these for renderings. We can use them for just visualization in general without using site photos. We used to take a lot of site photos in order to generate models, to create models, and just by utilizing this point cloud, we avoid switching between the model and just photos in general. Just using Recap and Revit is sufficient to figure out some of these building details. And the other benefits of utilizing these types of point clouds are the small file size. This file size, I think, is just 2 gigabytes for the entire building, whereas the one that you saw previously, that was a decimated point cloud. So this is not full res. That came from the scanner. I believe that one is about 60 gigs, and this one, the decimated point cloud, is about 12 gigs. So we got it down from 60 to after decimation, this is 12 gigs, and then we're able to get this point cloud for about 2 gigs, right? So for the architects or people that don't have powerful machines, this is quite an improvement to be able to utilize something that is small in size. It provides great visualization, and more than that, is freaking accurate. So if you overlap these 2 point clouds on top of each other, it's very hard to tell them apart. So we can switch now to Revit and show you for 1 minute how crisp this data is. All right, so this is this is one data set, and we're talking about like very rough masonry. This is the oldest masonry building in Georgia, so it's pretty rough in terms of the surface. So you might say this is pretty noisy, but what I can do is quickly bring in another point cloud in here that was generated using the same method, and I'll show you how crisp the data is. So I'm gonna turn this one off. Actually, I'm going to remove it completely. Then look at this point cloud. So this is also generated using photogrammetry and laser scanning. And you know, you look at the interior walls, and there's not a lot of noise compared to what I used to see in the past. This is extremely clean. So we're looking at some cross sections, and we have the sills we didn't have before. You look at these profiles, and the data is extremely clean. I mean, this can be used for modeling. So you can definitely supplement your scan data using this process, and you get a lot of benefits. You know, small file size, great colorization of the points, and then high accuracy. You know, again, if we overlap the one that we capture with a scanner, there's almost no difference between them. So I want to stop here because, you know, almost close to the hour.
Yeah, and we do have some questions. I have a question just because I want to clarify something.
Yep.
So you're bringing the scans into capturing reality. Are you really only bringing in the images, or are you bringing in the images and the scan data?
So RealityCapture converts the scans at the initial import in those LSP files. So you know, based on what I read, they say they're bringing in the scans, but I believe they're just those images, and they're extracting type points from those images in a way that's not allowing them to move. So that's what it gives the accuracy, that anchor that you can tie the other data to.
I would imagine since they can get a range for any pixel, they're probably getting the location of each one of those pixels, basically with a range map or something. That's really cool. That's really interesting because you know, they're not using the full resolution scan data. It didn't look like, but they're
no, because you know, if they were, when I exported the final point cloud, I would have gotten the same number of points, but I didn't. I got, you know, less points, but sufficient points.
Yeah, more evenly distributed points, which is why you have more.
Yes.
That's super cool. All right. Let's see. Philip Delaire asked, are you working with JPEG files that you're bringing in, or are you working?
Yes, JPEG. Yeah, okay. Shooting in RAW and then making adjustments in Lightroom, and then exporting JPEGs from Lightroom, and then bringing JPEGs into RealityCapture.
Awesome. Thomas Cernesk. Oh man, Thomas, I did it again. Cerniowski. Thomas asked, have you found a good photogrammetry solution that accepts 360 photos and videos as inputs?
I haven't tried that, to be honest. I know that RealityCapture has a video option, but I haven't tried it. Right? Yeah, I don't know how you, because 360 photos, they're quite blurry. I mean, there's some good cameras out there.
In the lens.
Yeah.
Yeah, I know there's some tools out there that work with Instruction Site, Reconstruct. There's some things for construction job walks that use it because they're not really trying to get accuracy out of it. That'd be an interesting thing to see, but I know the issue that they run into is just all the distortion in the lenses means you just really can't get this level of accuracy out of it.
Yeah, even with the with, you know, 18mm lens, you get some distortion. So I know that RealityCapture adjusts for that distortion. I don't know how it will do for 360 cameras though.
Yeah. All right. And then okay, I think we answered that question already. All right. Have you okay? And then actually, you Thomas also asked, have you tried workflows with thermal or hyperspectral imagery?
No, I have not. No.
Okay. And I know with thermal, one of the things people struggle with is the thermal images tend to be much lower resolution than the actual than RGB images, and so that always creates kind of a challenge in matching up feature points and type points. Let's see. Have you ever just used the photogrammetry without any laser scan data, and how accurate is that?
I mean, it's pretty accurate as long as you have something to scale it. So you need some like I forgot what it's called, but it's basically just a a rig that you have, and you need to select points on that rig, and it's a known distance. As long as you have a way of scaling your data, it's pretty accurate. Unfortunately, it's not level, so you also need to figure out how to level your data. But you can find ways of that without using the scan data. I guess the beauty about using scan data is, one, how the data will be positioned, right? And then the other thing is, think about a large building. I just showed a small building. On a large building, you can go and just scan your entire building, but you might need high resolution or high definition point clouds just in certain rooms. So you can just go and then take photographs only of that room and then just process that area. You don't need to do the entire building. So I guess that's the beauty of using this workflow. You can just pick whichever area you need to to increase or augment your point cloud.
Gus Rios wants to throw out, thank you. It was an awesome demonstration. He's rarely impressed when watching 3D scanning demonstrations, but this one did it, so good job. And then one last question here. Similar workflows, this is Peter Lindblom, similar workflows here, but any success doing the same on interiors?
Oh yes, yeah, the lighthouse, that's cross sections that I showed at the end. That was a full exterior photogrammetry. So I tied all those rooms together and using multiple subcomponents, and then I used the scan the same way as the rig, and it worked extremely well.
By the way, is that the second one you uploaded, Silviu?
Yes, that okay. Is, yeah. It will be available online for viewing.
Yeah, we'll post it online for viewing as well, and that way people can take a look at it. Fantastic. And then one last thing, I'm really curious to know. I'd love to try. This is taking a much more sparse scanning approach. So scanning mainly to provide control for the photogrammetry. I'm very curious what that might do, what you might be able to achieve with that in terms of field time. So, scanning, instead of doing, 30 setups on a job like this, doing, 4 or 5 setups, and then, still using that to get the accurate photogrammetry and what that might do in terms of time savings and output.
So I think that's a workflow that is used quite a lot from a lot of the posts that I saw out there. Companies that they only do photogrammetry, that they do this for creating meshes for visualization and gaming, for instance. They only do a handful of scans, as you said, just to provide control. They do scan at the proper resolution, but they just do 10 scans, 5 scans, and that's going to give them the proper location if they're geo-referenced and the scale.
All right, that's awesome. We have a question just popped in. Do you attach high contrast control points to your scanned objects? It's from Rex Donahue.
Say that again. I'm sorry, I didn't get the first part.
Attach high contrast control points to your scanned objects. Have you tried that, I guess?
High contrast control points to my scanned objects. Not necessarily. I mean, I saw that you can do that for smaller objects. I mean, we do use targets, and those can be used as control points. You can extract them in RealityCapture. So if you do have somebody that can shoot those targets for you, you can definitely use them and skip the scanning part. But I haven't tried them personally. I mean, one thing that I can do is export the coordinates from Cyclone of all those targets and try to load them into RealityCapture as ground control points and see what happens.
Yeah. Forrest Huff is asking, he wonders if phone captured LiDAR scanning and photogrammetry integration would get similar results.
I don't think so. I mean, you get some, I mean, I saw some good results out there, but I haven't tried it. I know there's somebody, I forgot his name on LinkedIn, that does like every day does a test. And in some cases, the results are quite astonishing. Some other cases, you know, kind of quite rough. But you can definitely take photos with your phone and the results are pretty good.
Yeah, I think it kind of comes down to the size of the objects. Like,
Yeah.
you know, the phone LiDAR is just so short range. You get so much drift over any long range that you run into problems. So I did see a cool YouTube thing where somebody plugged the phone into an RTK dock. So they were getting RTK correction on their GPS instead of using the phone's GPS, and got some pretty good results on a, you know, outdoor relatively large scale job. So that was pretty cool. And then one last, can you do the same project just using Recap? I think it can combine the two as well. Can you talk to that real quick?
Using a recap photo?
Yeah.
I haven't tried that. I mean, I've used recap photo just to do some cool meshes, but I've never tried to combine the two together.
So
you know, terrestrial and photogrammetry.
Yeah, so Recap Photo will make a photogrammetric mesh. And of course, in Recap, you can register laser scans, but Recap does not have any ability for you to connect the photogrammetric mesh to the point cloud. You can register them together, but they will each be their own little thing registered together. And so you will not.
I mean, there will be different files. They can see them in the project.
Yeah, but you will not get results like this. You will get a mesh that looks like it came out of Recap Photo without the correction of the laser scanning, and then you will have a laser scan, and they will not necessarily line up in a lot of places.
And then, you know, you need to look at, you might be able to obtain some good results with other tools. There are a lot of other tools out there, but I'm always looking at what like professionals are using for large projects, like, you know, somebody like SciArc. What is the movie industry using? What is the gaming industry using, right? Because they can get some pretty awesome results, and they're all using, you know, a similar process, and they might be using RealityCapture or a similar tool, but they're all like, you know, top of the line when it comes to processing power and results. So,
all right, let's wrap that before any more questions pop in. We're already 10 minutes over. Thank you, everybody that stuck around to ask questions.
Thank you. This was cool.
Yeah, and thank you so much, Silviu. This was an awesome session.
Yeah, and if you guys have any other questions, I know we didn't cover the last two steps. You can reach out to me or reach out to Kelly, and I'll be happy to show you more.